Hi students, this is Yashpal. I will be teaching you software architecture and design patterns course. I wish all are doing great. There are two textbooks for this course. One is Object Oriented Analysis, Design and Implementation. The another one is on Design Patterns. In this session, we will be discussing about Introduction to Object Oriented Paradigm. To understand this paradigm, first we must know what is object oriented. The word object-oriented means object plays central role. Elements of a given situation are decomposed to objects and object relationships. Next, let us see what is object-oriented development. Traditional view of a computer program are automating a well-defined process and translation from natural languages to a sequence of operations that could be executed on a computer. What traditional view could not fulfill. So those are behaviors that was hard to characterize as a process and requirements of reliability, performance and cost were not being addressed at all. The traditional approaches were the process-centered approaches, which used a top-down functional decomposition. First step in this design is to recognize what process has to deliver, followed by decomposition of a process into functional modules. Structures stores the data and computation from which the data can be manipulated. Now we shall see what is the drawback of a process-centered approach. Short lifespan. Changes in a process specification requires to change a complete program. What needs to be done in object-oriented? Defining software solution as collection of objects. These objects interact through well-defined interfaces. Software object is designed to handle multiple functions and store data, not implementing end-to-end monolithic process. Analyze the entire set of process, identify necessary software components, each components designed to store information along with procedures to manipulate the same. Now we shall see key concepts of object-oriented design. The central role of objects. Notion of object is centered around a piece of data and the operations or methods. Creation of abstraction is very simple. Entire system is assembled from the objects. The notion of a class. Classes allow software designers to look at the objects as different types of entities. This allows classification of these types, defining hierarchies and ideas of specialization and generalization. Abstract specification of functionality. Properties of objects that are needed by a system. No restriction on how functionality is achieved. Specification called as interface or abstract classes. It is just like contract for a implementer. And another key concept of an object-oriented design is a language to define the system. Unified modeling language is used to represent the systems. Documents generated in UML can be universally understood. Standard solutions. Object structure facilitates the documentation of standard solutions called design patterns. An analysis process to model a system. Object orientation provides systematic way to translate from functional requirements to conceptual classes. Development process translates conceptual classes to implementation classes. The notion of extendability and adaptability. Inheritance. creates a new descendant class that modifies features of an existing class, that is ancestor, and composition. Other related concepts. Changes in software design which affects the object oriented concepts and methodology are being discussed further. Now we shall see about modular design and encapsulation. Many number of distinct components are developed independently. These components are integrated to meet required functionality. Thus, system functionalities are specified by interfaces. These interfaces specify how components communicate with each other. Modules hide implementation details, which is known as encapsulation, and abstract data types perform operations without concerning with the implementation. Now we shall see how cohesion and coupling affect system functionality. Cohesion of a module tells how well entities within module work together to provide functionality. If responsibilities of a module are unrelated or varied and use different set of data, cohesion is reduced. High cohesive modules tend to be more reliable, reusable, and understandable, whereas coupling refers to how dependent modules are on each other. Modules may refer to variables and use methods in other modules or may use returned values. Low coupling allows to modify a module without worrying about ramification of changes on a system, but high coupling may have domino effect during changes made in the module. Another concept is modifiability and testability. Modifiability allows modifications to be done for changing both functionality and design. The ability to change functionality of a system is said to be adaptable. Testability is ease with which bugs can be detected, unit testing over their prominence. Benefits and drawbacks of an object oriented paradigm. First, we shall see what are the benefits. Objects reflect entities in application systems. Object orientation helps increasing productivity through reuse of an existing software. That is, inheritance makes extendability and modifiability easier. Changing requirements can be isolated in a parts of a system and also easy to accommodate the any of given changes. Ability to isolate changes, encapsulate the data, and employ modularity reduces risk in the system development. And the possible drawbacks are reduction in efficiency, since it introduces many layers of software which increases an overheads. Object creation and destruction is very expensive. More number of objects lead to poor memory access times. Thank you.